you ever heard of a solar-powered vehicle? What if I told you there was a solar-powered vehicle that could move at 45 meters per hour? Would you be impressed? That's meters per hour, not miles per hour. What if I then told you that vehicle was a train of water molecules all connected together, powered by evaporation? Does anyone know what process I'm talking about? That's right, I'm talking about evapotranspiration, or just transpiration. That's the process in plants by which water is drawn up through the plant's roots, goes up the trunk of the tree, and evaporates into the air. First, I'm going to talk about some of the properties of water that make transpiration possible, and then I'm going to talk about the steps of how the process works. Let's start by talking about some of the properties of water. Each individual water molecule that makes up liquid water consists of an oxygen atom bonded to two hydrogen atoms. In each of these bonds, two electrons, negatively charged, are shared between the oxygen and hydrogen atom. However, the oxygen atom is much larger, and so it attracts the electrons more strongly, giving the oxygen atom a partial negative charge and the hydrogen atoms a partial positive charge. For that reason, the two sides of a water molecule have totally different charges. This results in a phenomenon called hydrogen bonding. This is a strong bond between all of the individual molecules that make up liquid water. Hydrogen bonds are very strong, and they occur because negative charges attract one another. This results in several interesting properties of water. The water molecules binding together to one another is called cohesion. Adhesion is another phenomenon that can occur. Adhesion occurs when the partial charges on the water molecules attract them to other surfaces, like the leaf surface, as you can see here. Another interesting property that results is surface tension. This creates sort of a film on the surface of liquid water. It also results in a group of water molecules wanting to take the shape that will give the group of water molecules the smallest surface area possible. That's called surface tension. Now that you understand some of the properties of water, let's talk about how they make the process of transpiration possible. We're going to talk about how water is drawn up through the plant's roots, goes up through the trunk of a tree, and is able to come out through the top, evaporated into the air. So the first step in this process is when water with nutrients in it is absorbed into the root hair cells in the plant's roots. The water and nutrients are absorbed into these cells, and they move throughout the cells into the center of the plant's root, which is also connected to the center of the rest of the tree. As this water moves, individual cell membranes absorb some of the nutrients, giving the plant fuel that it needs to grow. In the next step of the process, a long tubular column called the xylem, which is made up of dead hardened cells, is what carries the water molecules along. The water molecules are bound to one another by cohesion, and they form kind of a long string, or a rope that's pulled upwards. Adhesion also acts, allowing the cells to be attracted to the sides of the xylem, which acts against the force of gravity, allowing the molecules to travel upward against the force of gravity. The way that this pull is generated is at the surface of the leaf in its individual cells. The cell walls of leaf cells contain microfibrils, which are little bundles of straws. These are connected to the outside air. As water evaporates from the surface of the leaf, it creates a dent in the water surface that is connected between these microfibrils, as you can see here. That dent is something that surface tension of water wants to act against because it increases the surface area. So, as evaporation happens, it draws in new water molecules from the xylem. This generates a tug that goes throughout the whole column of the tree, and all the water molecules kind of create like a little rope or a train. They're all strung together, and water is drawn up from where it's evaporating all the way down from the roots of the tree. So, I hope that you have a better understanding now of the properties of water that make transpiration possible and how it works. Maybe next time, when you step outside, you will have a much better appreciation for just how much that tree is doing and how many factors work together to allow that tree to transpire. It's pretty amazing. Maybe you wish that your morning commute was just as easy.